Well, I apologize for being so late. I dropped my son at school. Those of you that were in my physiology class last semester know that he went to the hospital repeatedly for asthma, 4 or 5 day stretches at a time. Well, since October 1st, he's been in 6 times, and the last time was the weekend just before classes started, and they finally put him on another medication called theophylline that acts a bit more systemically and inside the cells, smooth muscle cells of the bronchiole and bronchi to inhibit phosphodiesterase as well as activate the adenosine 1 receptor and makes the cells basically unresponsive, stops them from spasming, makes them unresponsive to stimuli. Although he was resistant to virtually all other treatments. It's a slow release, acts like caffeine, it's xanthine, so he has to have it on a regular schedule. So I had to buzz home, get his pill, and get to the school nurse, and also bring him his breakfast and all that stuff. So don't need any more trips to the hospital. It really interferes with things. So let's begin then with Lecture 4, and we'll proceed to Lecture 5. We had covered the first couple slides already, so I'm not going to review the anatomy of the uterus, except to say that we are now beginning to focus on the endometrium, the innermost lining that we know is produced to sustain, or to allow implantation and to sustain the pregnancy. And we established the fact that the sustenance of the pregnancy or the promotion of gestation is due primarily to the progesterone, of course, coming from the corpus luteum. But we'll proceed to discuss this anatomy in a bit more detail, as well as the endocrinology of the human female menstrual cycle. Well, this is a high magnification of a portion of the endometrium. We start at the surface, the interface with the uterine cavity, or lumen, and we see that there is a simple cuboidal epithelial lining of that surface that is covered with a secretion during the secretory phase of the menstrual cycle, at least, by the uterine glands. We'll do the vasculature in a moment, but what we see as we follow the duct of the gland deep down into the secretory portions, we see that this one bifurcates, and the deeper portions are the secretory portions. Those deepest portions, the lower 1/3 maybe, let's say, lie within a layer of the endometrium called the basal layer. The layer from the basically the first branching, at least in this illustration, of the spiral artery that we had mentioned before, and the extent of that 1/3 lower gland is the point at which no more of the endometrium will be lost during the menstrual phase of the menstrual cycle, during menses. So the functional layer is the portion from there on up. Functional in that it produces the vascular arrangement and the secretory structures to promote the implantation and sustain a pregnancy sustain gestation throughout the pregnancy or the full gestation period. Well, we see that the spiral arteries branch into arterioles that proceed to the layer of the decidual cells. We'll describe that in greater detail when we talk about the implantation and everything. Just subjacent to the epithelial lining, and forms a rich capillary bed, and these large venous type structures, or lacuna, the venous spaces. So obviously we want to have a rich capillary supply and a venous pool to pool the blood to deliver the, well, to bring and wash away, as we know all the blood does, to the early implanted embryo or blastocyst, and then embryo. And then ultimately, when the embryo is fully implanted, to begin to form the vascular relationship, the hemochorionic type of relationship between the chorion of the placenta and the maternal vasculature in the endometrial lining. So obviously these venous lacunae will also have branches, venules that coalesce to form larger and larger veins draining back for the venous drainage. That's just not illustrated here. As well, there's a rich arterial and venous and capillary bed supply to the glandular portion, because it's the plasma that is the source of the fluid for the liquid content of the secretion. And then obviously all of the cells that make up the remaining layer, those decidual cells that I referred to, have a rich capillary bed as well. So a tremendous amount of energy supplies, all the essential nutrients, everything that, lipids, carbohydrates, and proteins, or at least the precursors for proteins, will be stored in those decidual cells. So it's delivered by the vascular system. They have a high metabolic activity when they're building that reserve up, so there's a lot of waste to be removed. We'll talk about, we know that functional layer is lost during menses, and it has to be replaced during the proliferative phase. So there's a lot of metabolic activity during that proliferation. The uterine tubes, as we know, are very important. There are other terms for them, salpinx, or fallopian tubes, or oviducts. They're virtually used interchangeably. We know that they provide the tube through which the egg, fertilized egg as well, will move toward or will be moved, let me say, because it's an active process, be moved toward the uterus. The salpinx are the site of fertilization, and of course, if a zygote is produced, it will be undergoing its first series of cleavage or division within the tube on its way to the uterus for implantation. So here again we see the portions of the uterus, the body with the fundus projecting above, the horn indicating the junction with the salpinx or the uterine tubes. The isthmus is the narrow portion leading to the cervix, and of course the cervix projects into the uppermost portion of the vagina. So we are imagining the fertilized ovum, the ovulated ovum becoming available in the peritoneal cavity to be drawn into the uterine tube by the fimbria of the infundibulum, the funnel-shaped portion. And then there's an initial dilated portion, the ampulla, and this is the most common site for fertilization to occur in the ampulla. Then the tube narrows, the isthmus, and enters through the intramural portion within the wall, intramural, of the horn of the uterus, and opens into the uterine cavity. The reason for understanding this detail is that if there's ectopic pregnancy, any tubal pregnancy, obviously it's very risky, especially if it ruptures, and most especially if it is implanted within the isthmus, the intramural portion. The isthmus is dangerous. Any of them are dangerous other than the ampulla, infundibulum. It may fall out and be a peritoneal implantation, which can go to full term. Obviously C-section, not a natural birth. But within the intramural portion, if it does rupture, then you've got the extensive vasculature of the uterus, the endometrium, causing severe hemorrhage. Well, here's a histological slide, and we are asked the question, the highlighted cells perform what? Well, let's get oriented to it first. Here we see a clear area, very likely lumen of something, the surface of something. We see these long extensions on the surface of the cells. Not all of them have them. Obviously, these highlighted cells do. They're very tall cells. Looks like all the cells have attachment to the basement membrane and an apical membrane that reaches the lumen of the structure that we're trying to determine here. All the blue nuclei seem to be aligned pretty much in the same area. This makes us think that it's a single layer of cells, epithelial cells, taller than they are wide, so columnar. So this is very likely a simple columnar epithelium. And what do you think are these structures on the surface of a large number of those cells? Cilia. So I always try to do a joke. Well, that was cilia, yeah? Never works either. Just really can't really work it in, but I always hesitate there going, how can I work that in? So what will these be doing? You know, they'll be moving in the direction, their power stroke is going to be in the direction toward the uterus. It'll be moving peritoneal fluid along through the uterine tube into the uterus. And if the ovum or zygote is in contact or even just floating in the fluid, it will be moved toward the uterus. Of course, that's in the opposite direction of the movement of the sperm, but they've got all those mitochondria in their centerpiece and plenty of carbohydrates in the semen, I guess, to move them along. Although there's probably not much semen accompanying them through here, so I wonder where all the energy comes from. Anyway, then we see the basement membrane with underlying connective tissue. What's this structure here in the uppermost part? I can see that here anyway. What are those two things? Red blood cells. So this is it's pretty large. So it's probably a vein. So the vasculature is there. So the highlighted cells aid in the movement of the ovum, yes. Provide nutrients to the ovum, no. Are the secretory cells of the epithelium, no. Release estrogen and progesterone, obviously not. Well, we come back then to the primary organs, the site of gamete development, and we probably won't do much more than a cursory review because we've spent a good portion of time in discussing the ovaries with gametogenesis. So they obviously are responsible for gametogenesis, as well as having the endocrine function producing at least these two essential female gonadal steroids, estrogen and progesterone. And when we see those two terms, we basically think of two specific steroid hormones, estrogen and progesterone, or estradiol, which is the 17-beta estradiol, to be very specific, for the estrogen, and then the typical progesterone. But there are several others that are produced. So these are the female gonadal steroids, there are the estrogens, and the progestins, the general categories, and these are just two of those two categories. So there's a wide variety of other steroid hormones, estrogens and progesterones. But these are the two that are known to have the primary function. Well, let's back up for a moment and think of what is the trophic hormones. What are the trophic hormones for the ovary? We know they come from the pituitary gland, and they include FSH and LH. And I guess we're transitioning to the female cycle here, so let's draw our attention to that. The FSH, follicle stimulating hormone, will stimulate the development of the ovarian follicles and sustain or support the synthesis and thereby secretion of estrogen by the follicle cells, the granulosa cells. So FSH is responsible for the recruitment of a pool of follicles, primary follicles, to proceed toward the development of the single mature ovum. The luteinizing hormone will trigger the ovulation and stimulates the follicle cells in the corpus luteum to produce the progesterone. So we know from just this quick introduction to the two trophic hormones for the steroid and gamete-producing functions of the ovary, that we're going to see a progression through the menstrual cycle, the female cycle, from the production of estrogen predominantly to a production of progesterone. And it depends upon the nature of the cells being targeted in the ovary. So first we have the the granulosa cells or the follicular cells that will ultimately differentiate into the corpus luteal cells, and there's just represents a significant shift in the biochemistry of those cells. So the follicle-stimulating hormone is going to target the primary follicles and bring them through the development to secondary follicles and finally to the mature, and will bring about the production of the estrogen in the follicular cells. The ovulation will occur in response to LH, so there must be something dramatic that happens to LH during the menstrual cycle, and we know that there's an LH surge, and we'll see that in more of an overview in this lecture. What I'm considering doing is sharing the link to the general physiology pre-recorded lecture on the menstrual cycle that goes into more detail, and posting it on our site for those of you that want to view that and get a more complete review or lecture on the menstrual cycle. The corpus luteum is yellow body. The yellow, we said, was the cholesterol ester, the precursor for all the gonadal steroid and adrenal steroid synthesis, as we know, but especially in this context for estrogen and progesterone. So the follicle cells now have become luteal cells. They persist after the ovulatory event, and their biochemistry shifts so that much more of the biochemistry of the cell is dedicated to the synthesis of progesterone than to estrogen. This just means that there's been a shift in gene expression so that we're now expressing the genes for the biosynthetic pathway to bring some intermediate toward progesterone, and there's fewer or there's either more of those enzymes than there are for the estrogen, so there would be more of the intermediary molecules that are shared for both pathways drawn toward progesterone than for estrogen, and so you have a greater synthesis and secretion of progesterone than estrogen, but it's a vast amount of both, so you need that tremendous reserve of the cholesterol ester within the corpus luteum. So the degeneration of this is prevented by human chorionic gonadotropin secreted by the chorion. So it is not a self-sustaining structure. It's actually a suicidal structure in my own terms, because without human chorionic gonadotropin or conception and the ultimate very early secretion of this HCG, the corpus luteum is going to produce all these vastly high levels of especially progesterone and inhibit the pituitary and shut down the FSH and LH synthesis and secretion that has been sustaining it. So the HCG would come in if there's a pregnancy to make the pregnancy independent of the maternal pituitary. So this mechanism of the strong negative feedback of the corpus luteal hormones on the maternal pituitary to basically shut down FSH and LH, maternal pituitary FSH and LH, and become dependent on the HCG is rather specific for mammals and for humans to make the pregnancy independent of the maternal pituitary. It remains functional for 20 weeks if the pregnancy, the concepsus, continues to synthesize and secrete the HCG. And it degenerates 10 to 12 days, and actually it's more specific, 14 days. It's very reliable at 14 days for that suicidal timing. So after ovulation, the post-ovulatory phase of the menstrual cycle, if the egg isn't fertilized, the corpus luteum will self-destruct in that sense and will lose all the cholesterol ester and basically become scar tissue referred to as the corpus albicans, so a white body. Now we'll proceed through a series of slides that will take us through the the menstrual cycle. And again, it isn't the more elaborate presentation that I give in the physiology classes. So I'm assuming that you have some background in this area. And as I said, I'll post that other link so you can go and watch that if you want some clarification. Basically, what we need to think about is that ovulation is the midpoint, not really midpoint, but relative midpoint. It will be 14 days after ovulation for the end of a menstrual cycle, and that's the post-ovulatory phase. The pre-ovulatory phase can be longer than that. That's the phase that will vary from individual to individual and maybe cycle to cycle as well. Excessive stress can prolong that pre-ovulatory phase, or other things like starvation can even prevent the menstrual cycle. So we'll think about pre-ovulatory events and post-ovulatory events. And obviously there's things going to be happening in the uterus. We've already implied those. There's going to be, at the very beginning of a menstrual cycle will be the menstrual flow. So the, the menstrual phase of the menstrual cycle. And that will be followed by the proliferative phase. You have to replace it. And then after ovulation, with the development of the corpus luteum, those glands will gain their secretory capabilities, and we refer to that as the secretory phase. So we are picturing the uterus sloughing the endometrium. The first day of external presentation of the endometrial flow, the menses, is day 1 of a menstrual cycle. And we know that the endometrium, the functional layer is lost, has to be recovered, and then we have to get to the secretory portion of it so that the glands are secreting what's needed after ovulation in case there's a pregnancy. So there's the menstrual phase of the uterine cycle, the proliferative phase that is estrogen dependent, and then the secretory phase that is progesterone dependent. So we're going to see varying levels of estrogen and progesterone in pre-ovulatory and post-ovulatory events. We'll now take a moment and try to imagine what's happening in the ovary, because we've looked at the anatomy and histology of it already. When there is menstrual flow, in the pre-ovulatory phase corresponding to the menstrual phase of the uterine cycle, we know that FSH and LH levels will be a little bit higher. Corpus luteum's dead and gone. So the FSH and LH, the maternal pituitary, is released from that inhibition. So they're going to increase. So we're going to recruit follicles, and they're going to develop. As they're developing, the follicular cells are going to be producing more and more estrogen, and there's more and more follicles developing and more follicular cells. So estrogen levels are going to go high. That's the estrogen that's sustaining the proliferation of the endometrium. After ovulation, we get the corpus luteum. Progesterone levels are going to go up, and that will sustain the secretory phase and, of course, bring about the negative feedback on the maternal pituitary. So the FSH and LH levels would be dropping. So I'm challenging you to imagine that and keep that image in your mind, sustain that imagination as we proceed through these series of slides that really don't show this on a temporal scale so much. But this is the basic system. It's the hypothalamus up here, pituitary gonadal axis, the female HPG axis. The anterior, the hypothalamic hormone is gonadotropin releasing hormone, shown here in this legend A. So gonadotropin-releasing hormone comes from the neurons in the hypothalamus through the hypothalamic-pituitary capillary system, portal system, and bathes the anterior pituitary cells and will stimulate the secretion and synthesis and secretion of the FSH and the LH. And that FSH and LH, of course, is secreted into the venous, systemic venous circulation, goes to the heart, through the lungs, left heart, and then finally down through the descending aorta, through the ovarian artery, into the ovaries, and bounces around, as we had indicated before, within the ovary to bump into their corresponding receptors. So the FSH and the LH will stimulate the egg maturation, estrogen production, and other events. So this is a bit more generic, as we see here. So we are clear with this picture at the level of the ovary. We've just added the hypothalamus and the pituitary to our discussion so far. The blood levels of estrogen will rise and will stimulate a surge in LH secretion. So that pre-ovulatory production and sustained, ever-increasing production of estrogen through the first part of the ovarian cycle, the first phase of the ovarian cycle, which we didn't name. It's the follicular phase when we've got follicular recruitment and development, would, by our typical understanding of negative feedback, be causing an inhibition at the level of the pituitary. But as those estrogen levels are ever increasing day by day through the follicular phase, corresponding to the pre-ovulatory phase of the menstrual cycle overall, so before ovulation, they're changing the molecular mechanisms in the anterior pituitary cells targeted by GnRH, producing more GnRH receptors, increasing the gene expression for the GnRH receptors and inserting them into the membrane, and also increasing the expression of the FSH and the LH genes so that we increase the pool of LH especially that's available to be released. So rather than a negative feedback, we're actually getting a transition to a positive feedback, and then all of a sudden when estrogen levels have been sustained, increasing on a sustained level, there's a point where the anterior pituitary cells finally are just very responsive to the GnRH, and the rate of secretion of the GnRH changes, and they just dump LH and FSH, but more LH, and there's a big LH surge. Right after that, all that molecular stuff reverses. GnRH receptors are taken out of the membrane, degraded. We've dumped all of our LH and FSH, so we're back to basically normal reserve levels, and we switch back to negative feedback. So it's a tremendous molecular event that occurs at the anterior pituitary cells, induced by that estrogen very early throughout the pre-ovulatory phase of the menstrual cycle. And then that LH surge is what is going to stimulate the ovulation through another vast array of very interesting molecular changes, blood flow, activation of enzymes that are going to break down the connective tissue between the ovum, the mature ovum, and the surface of the ovary. So you have to soften that area and increase the pressure and all that, so that you can rupture the wall of the ovary and eject the ovum with the corona radiata. So there's a tremendous amount of molecular activity and biochemical changes that occur throughout the menstrual cycle. But basically, after ovulation, we are now at a point where we're again sensitive to negative feedback. So any estrogen and progesterone, especially that progesterone that's coming from the corpus luteum, is going to have a potent negative feedback. So FSH and LH synthesis and secretion by the anterior pituitary is going to decrease. So unless there's a zygote with HCG, we are going to eventually lose FSH and LH, essential to the survival of the corpus luteum. corpus luteum is going to degrade and no more progesterone, and the endometrium is going to be lost. So the rising blood levels of the progesterone and estrogen inhibit further LH and FSH secretion in the last phase of the cycle. So I'm just going to quickly go to the document camera to illustrate the menstrual phase on a temporal scale. I think it'll help just get us on track. The menstrual cycle has two other cycles within it, the ovarian and the uterine. And we've seen those events already. Everything is centered, of course, on ovulation. And I use the terms the general phases of the menstrual cycle. There's pre-ovulatory and before ovulation, and then post-ovulatory. So those are the two phases of the menstrual cycle. There are two other cycles with their own phases, as we had mentioned as well, the ovarian and the uterine. Basically from day one, we have FSH and LH increasing because the prior corpus luteum is gone. So FSH and LH can now increase. So there's follicular recruitment and development. So this is the follicular phase. So follicular recruitment and development here are going to increase increase estrogen levels. After ovulation, the one mature follicle becomes what? Corpus luteum, so this is the luteal phase. So the follicular phase of the ovarian cycle and the luteal phase of the ovarian cycle. So if we put the gonadal steroids in this box, and I'll use a continuous line for estrogen, estrogen levels are obviously going to be very high and then come down and then kind of go up again. So it's the follicular recruitment and development here that brings about this rapid and sustained ever increasing plasma concentration of estrogen that will cause the reversal from negative feedback to positive feedback and give us the LH surge. It's also going to be acting at the uterus after the menstrual phase. Can't get an M in there. After the menstrual phase, not the menstrual cycle, the menstrual phase of the uterine cycle, the estrogen here is going to be causing proliferation. So this is the proliferative phase of the uterine cycle. Okay, so the menstrual cycle has two cycles within it, the ovarian and the uterine, and the menstrual cycle has phases centered, if you will, around ovulation. The ovarian cycle has two phases, also centered around ovulation, and the uterine cycle has three phases centered around, or in a sense centered really isn't the right term there, but I'll keep using it, the ovulation. After ovulation, corpus luteum produces a large amount of progesterone, so let's use a wavy line for that. There is a little bit of progesterone, and then it just goes up really high, and then we'll come down. So this is the secretory phase of the uterine cycle. Right, so just thinking about follicular recruitment and development, and then ovulation and production of the corpus luteum, we can predict what the levels of estrogen would be in the pre-ovulatory phase and what the levels of progesterone would be in the post-ovulatory phase. And knowing what estrogen does to the endometrium after the menstrual phase, when the functional layer has been lost, we can predict the proliferative phase. So the basal layer targeted by estrogen is going to undergo tremendous mitotic activity, both it's vascular, the decidual cells, the surface epithelium will be regenerated, the ducts of the glandular cells. So a tremendous mitotic activity from the basal layer reproducing that functional layer. After ovulation, corpus luteum, lots of progesterone. It's going to sustain the vasculature of the endometrium, especially also the secretion from the glands that we saw. So if we back up to the FSH and LH, I'll just do the LH here. The levels of LH would increase because estrogen and progesterone are low. So the LH levels are going to increase, be sustained for a while, and then when the estrogen levels get really high because of follicular recruitment and development, there's that molecular change at the pituitary from a negative to a positive feedback. And so high estrogen causes, boom, an LH surge, and then it comes back, and then it's just gradually going to taper. The FSH is very close behind it. There's a little surge, and then it comes through. This LH surge is about 1 to 1.5 days before ovulation. And of course, the ovulation predicting kits that you can buy at the pharmacies are looking at LH in the urine. And those, of course, are not to prevent pregnancy. Those are to find out when you might be ovulating and to get pregnant. So we see after this switch from negative to positive feedback, we go back to negative feedback, and the high progesterone and estrogen levels bring the FSH and LH down to a low level. If there is no HCG or no fertilization, no zygote, becoming a blastocyst ultimately in an embryo, then the corpus luteum cuts off its own supply of trophic hormones and is suicidal. This is 14 days, and this is anywhere from maybe 12 days to 15 days. Any human female menstrual cycle can be 25, 26 days. Probably rare to be 25, but 26 days to 30 or so. So the 28 days that we always hear about is nonsensical. If you believe that and you say, oh, my menstrual period started 13 days ago, so tomorrow I'm going to ovulate, you're going to be a parent. The first day of menstrual flow, 14 days ago, you ovulated. So what did you do 2 weekends ago is more of the question, and will you be a parent for that? So as we're winding this down, let me just note that for the oral contraceptives, the menstrual phase is about 5 days, unless you're on the oral contraceptive, and it's actually 7 days because you're regulating externally, exogenously. You discontinue the contraceptive pill on one day, and either take the sugar pill or don't take it for a week, and that's when the menstrual phase will be induced, and you begin taking it 7 days later. At this stage of the menstrual cycle, actually through this very early part of the pre-ovulatory phase, the negative feedback is very sensitive. So what you do is you blunt FSH and LH. You don't eliminate it, but you blunt it. You blunt this increase in estrogen. You prevent negative feedback so you do not get an LH surge. If you don't get an LH surge, there is no ovulation. Ovulation only occurs, I'll feel safe in saying that, if there is an LH surge about a day and a half preceding. In addition, if you don't get this robust estrogen production from the ovaries, then you don't have the complete proliferation. Although if you get pregnant on the birth control pill, typically the gestation can be sustained, so it doesn't inhibit it completely. And if there is a corpus luteum produced, then typically there shouldn't be much of any secretion, because if you block ovulation, there's no luteal phase, and there's no progesterone at significant levels to trigger a full secretory phase. The mechanism of action of the oral contraceptive pill is at the level of the pituitary, causing inhibition from the very beginning, keeping everything blunted, but most importantly, it blocks the LH surge and prevents ovulation. So it is a true contraceptive. A contraceptive, by strict definition, is against conception, right? So contraceptive will prevent conception, will prevent union of the gametes, so there can be physical barriers like the diaphragm or the condom or spermicide. Those are, to varying degrees of effectiveness and reliability, true contraceptives. Does anybody know what RU486 is? RU486 is a progesterone receptor antagonist. It actually was developed as a corticosteroid receptor antagonist, but had a high potency for progesterone receptors as well. So given at any time during secretory or, proliferative or secretory phase, it will trigger the loss of the functional layer. And so if it is used after coitus to prevent any suspected pregnancy, even if a pregnancy isn't confirmed, it's an abortifacient. Anything that does not prevent the union of the gametes is an abortifacient by definition. So it's not the abortion that we think about of yanking and crushing the head and shoulders, the most controversial one, down to the one at the D and C of classic history when they were illegal, dilation and curettage. It proceeds all the way to the level of any approach that doesn't prevent the union of the gametes. Well, I'll stop there, and again, I appreciate your waiting for me, and I'll see you on Monday.